We're going to talk about conditional probability. We're going to break this section up into a few different videos because they all play a little bit differently and seems to make a little more sense. I try to mostly, if things break naturally, to make shorter videos, right? So the conditional probability, we've already looked at some of these questions throughout the semester. The conditional probability, the probability that event A happens given that event B has already happened. This is the probability of A given the condition that B has happened. I'm just going to say it that way. The probability of A given the condition that B has happened. That's a conditional probability, right? Sometimes this matters and sometimes it doesn't, and that's one of the topics we're going to talk about. But let me give you an example when it does. Suppose I say, go out to your car right now and try to start it. What's the probability that it's going to start? And you might say 0.99, right? My car starts all the time, or almost all the time, and that's probably true for most of these days. Back in the 70s, cars didn't start as much, but nowadays cars almost always start, right? On the other hand, if I'm allowed to, if I'm allowed to put a precondition on that, I'm going to say it's 30 degrees below zero outside and your car is parked outside. Now give me a probability, right? Is that probability going to change? And the answer is yes. It's very hard for cars to start when it's 30 below, right? It takes that much more, everything gets cold and they don't want to start. And so that's a conditional probability, the probability that your car starts given the condition that it's 30 below outside, right? Just as an example. Now the notation for the conditional probability is this. I try to use the word given a lot when I do the conditional probability. The book uses the word if a lot. So if B has happened, or the car starts if it's cold outside. Where I use given, so A given that B has happened. So the probability of A given B, that conditional probability, the notation looks like this: probability of A given B. Now that line technically goes straight up and down, but I'll often slant it a little bit because the formula is the probability of A given B equals the probability, well, you're only looking at the conditional probability only when B has already happened. So you've now restricted yourself to only the situation where B has happened because you said, hey, B happened. Well, if B happened, then you're not looking at the whole group, you're only looking at the B's, right? And of those B's, what's the probability that A happens? So you have to look at only the A's that are inside B, so only the overlap of the A's and the B. And I kind of, when I'm saying that, I often say, okay, we're restricting ourselves to the denominator, and the conditional probability is the only probability that has changed our denominator. And then once we're inside that B, you also have to get A. And that's your formula. And we'll do some work with the formulas, not in this first lesson so much because we're going to try to do everything with counting in this first lesson. But that is the formula, and we'll run into that again, right? So let me do a Venn diagram. A sample space question. So so we roll 2 dice. What's the probability the total is 5, let's say? Well, I'm not going to draw that sample space on the board again. Probability the total is 5. You can either get a 4-1 or a 1-4 or 2-3 or 3-2. And so that's 4 out of 36, right? What's the probability that the total is 5 given that at least one die is a 2? It was a few lessons ago, a few videos ago especially, but how many of those rolls? So this is what you have to ask yourself. The denominator is set by the given. The given sets the denominator. A lot of people think because you read this part first, the total is 5, that's your denominator. No, this is the situation you're restricting yourself to, the given. At least one die is a 2, right? So how many rolls have a 2 in them? Well, 11 rolls, and we counted those out a few lessons ago, right? 11 rolls have a 2 in them. And of those, now this is where the numerator comes from, of those, how many total up to 5? So there's the 2, 3, and there's the 3, 2. And the 1, 4 and 4, 1 don't count anymore because we're only looking at rolls with 2s in them. So 2 out of 11, right? On the other hand, what's the probability that the total is 5? And one die is a 2. I guess I'll erase this. There's no given here. There's no conditional probability here. There's no restricting the denominator, right? I'm just asking for this situation. So the denominator is 36 in this case. You've got to recognize when it's conditional, when it says if, or when it says given, right? Or when it says on the condition that. Total's 5, and one of the dies is 2. That's a 3, 2, and a 2, 3. That's 2 out of 36. So learn to recognize, and the word given is the one I try to use most often, but the book uses the word if a lot, right? When you have those sample space questions, you can always do questions by just counting, right? And this is a counting question. Another situation where you can just count is when you have a contingency table. Contingency tables I really like for conditional probabilities because it's easy to count them, look at them and count, and it really, I think it shows some pretty good understanding. You have to understand what you're doing. So if we have, we went out there and we did a survey and we did males and females. This is my favorite contingency table example, of course. Because I try to offend everybody. Males, females, Republicans, Democrats, and independents. We already did this once. I'm sure it wasn't the same table with the numbers because I never bother using the same numbers. But and once again, we're going to do Central Pennsylvania, so there's going to be more Republicans than Democrats. So please try not to get irritated with me and think that I'm, favor Republicans or whatever. Right? Or males or females, but whatever, you can be mad at me if you want. So with that, we went out there and we did a survey and we came up with 26 male Republicans and 22 male Democrats and 13 male independents, 35, total of 61 males. Assuming I did that right, 48, yeah, that looks right. And came up with 32 female Republicans and 27 female Democrats and 8 female independents, 35, 67. And that's a total of 128 and 58 Republicans and 49 Democrats and 21 independents. Those should add up to 128, and so should these, and I think it looks like they do, so we're going to go with that. Okay, what's the probability that somebody's male given that they're a Democrat? What's the probability that somebody's male given they're a Democrat? Now, this shouldn't be a formula, you should be able to count this. So what are we restricting ourselves? We're restricting ourselves to the Democrats. So what's the denominator? Well, if we're restricting ourselves to just the Democrats, then the denominator is 49. I'm not looking at anybody else, right? Only the Democrats. And of those Democrats, how many are male? Right? Well, male is 22. Okay, so you're only looking at the Democrats, so you're only looking at this column. Total is 49, males are 22. You don't want all the males, you only want the males that are inside the Democrats. Or what's the probability that somebody's Republican given that they're female? So now we're restricting ourselves to a row, not a column. Our given is our females, so there's 67 of them. 67 females, and of those 67, how many are Republican? The answer is 32. So 32 out of 67. That's a 3, by the way. Okay, 32 out of 67. Or what's the probability that somebody's male and independent? Well, that's not a conditional, that's not a given. It's the probability they're male and independent, so 128, we're back to our original total, and of those 128, 13 are male and independent. There's 13 right here. What's the probability somebody's male, well, I'll go back to females, female or Republican? So female or Republican, we did this back when we did lesson 2. Female or Republican, we've got our females 67, we got our Republicans 58, but we have to worry about what we double counted. So this is going to be 67 females plus 58 Republicans minus the ones we counted twice, 32, and this is divided by 128. This is not a conditional, right? So let's see, that's 26, 67, 73, 93 out of 128. We could also do that by the complement, who's not female, we're right here, who's not female or Republican. Well, these two. So that's 35, 128 minus 35 is 93 out of 128, right? So I really like contingency tables for the conditional probability because it's like you're counting, but hopefully you get good at identifying, oh, this is the given, let's restrict ourselves to that, right? And then this, within that given, how many are this particular category? Okay? I'm going to call that good for the introduction to conditional probabilities. I'm going to do some Venn diagram stuff in the next video.